Hey guys, this is Eli, the OBD Tech. I'm here working on a 2006 Chrysler PT Cruiser. I'm going to attempt to diagnose a pending code, which is a P0303 cylinder 3 misfire detected. It seems that the computer hasn't made this pending code as a severe problem yet, so it still has it as a pending. The vehicle does have some permanent codes which were actually triggered by me. You know, I actually had the connector disconnected for a moment, which triggered these 4 codes: a P0508 idle control system, circuit low; intake air temperature sensor, circuit high; P0108 manifold absolute pressure, circuit high input; and a P0123 throttle pedal position sensor, circuit high. And like I said, the connectors were actually disconnected, so that's why, you know, these codes are stored as a permanent. But the main focus is at pending code. This vehicle does have a rough idle, a slight misfire at moments. So in this diagnosis, you know, I'm gonna look at the scan data by looking at the fuel trims, short term and long term, and also at the O2 sensors. I will also try to give you guys some waveforms on the secondary ignition system. I'm gonna give you some resistance checks on the primary, secondary circuits for the ignition. I'm gonna try to ohm out the ignition wires. Maybe do some visual inspection on the spark plugs. So far, like I said, I'm not sure, you know, what's causing this pending code. Is it ignition, fuel, or mechanical? Supposedly stuck or leaking valves. I'm not sure, but so this first step I'm going to do for you guys is to look at the scan data. I'm going to set it up. I'm going to select parameters. Look at the short term, long term, RPM, upstream O2 sensor, and downstream O2 sensor. So I'm going to start the engine for you guys. So just by starting the engine, I do feel a little bit of a roughness, a slight misfire, but not severe. I'm going to hit live data now. Alright, so the computer currently has a long-term fuel trim at 3.1%. This is at idle. Short-term is fluctuating between positive and negative, which is good. It's close to 0%. O2 sensors are working. I guess we're actually in closed loop now. The upstream O2 sensor is fluctuating normally between rich and lean. Downstream O2 sensor, it's at 0.685, 0.7, but it's steady. So, like I always do, guys, I like to raise the RPM and look at the long-term, short-term fuel trims, and see what, you know, how these fuel trims react to higher RPM. So I'm gonna go 1500, 2000, 25, 3000, finally at 3500. So here we go, 1500. So at 1500, our long-term fuel trim went to 9.4%. So right there tells me there's a possible indication of a fuel delivery problem. This vehicle doesn't have a mass airflow sensor, it's a MAP sensor. Short-term fuel trims are more in the positive side than negative. I'm gonna go 2000 now. So around 2000 RPM, long-term fuel trim and short term are above positive 10%. That's right there. To me, it indicates a fuel delivery problem already. Our long term went to 13.3 now. Let's go 2500 now. So at 25, the long term is still at 3.3. Now short term is trying to counter the long term by going negative. It's actually trying to remove fuel. But long term is still 3.3. It still indicates a fuel delivery problem, perhaps restricted injectors, or maybe a fuel pump that is not delivering enough pressure to the max. I'm gonna go 3000 now. So at 3000, our long term is still actually went from 13.3. So just close to 3000 RPM. Our long term is still at 3.3. But it seems that as soon as I go above 3000 RPM, a long term drops to 2.3%. Right now our fuel trims seem to be normal within that plus or minus 10%. What if I go 3500? So at this point, at 3500, long term is still stuck at 2.3. Short term is fluctuating in the positive fuel trims. So just by adding both short term and long term, at this moment, we're close to almost 10%. So as you saw here on this fuel trim test, that just about 3000 RPM or long-term fuel trim is still at 3.3, but as soon as I go above 3000, it dropped to 2.3. This could be a, but so far to me it seems that it's going to be a fuel delivery, since this vehicle doesn't have a mass airflow sensor. But as you saw, that after 3000 RPM, long term became normal. So the next step is to go to the engine bay and hopefully perform these tests. I'm going to try to give you guys some waveforms on the secondary. Alright guys, so I'm here showing you guys on cylinder number 1. I'm going to compare 1 to 3. So I have, this is a waveform that is actually paused at frame number 11 of 25. This is just at idle. I'm going to show you guys the transition went from idle to a snap throttle. So right now our waveform is showing pretty much normal, 9.6 kVs. Our duration on our burn time is showing about 1.5 milliseconds. Usually a burn time, ideal burn time should be within 1.5 milliseconds and no lower than 0.9 milliseconds. So at frame number 12, that's the way it looks. KVs are 17.1. 13th frame, KVs dropped. Frame number 14. 16. So finally at frame number 17, that's where our spark fired, which gave us a very high KV, which is not really good. Supposedly specs should be under 20 kVs. This one's all the way to 32 kVs, which basically indicates the potential lean fuel mixtures, as indicated in our scan data when we did our fuel trims. It showed that we have a fuel delivery problem. This high KVs could also be due to high resistance in the plug wires or worn spark plugs. So after frame number 17, it went back, it dropped. Look at our KVs, it was at 0.1 KVs. And then went back to normal. Burn times within 1.5. Still look, that's a good waveform after the event happened. But let me go back to that frame 17 and let's look at the voltage after the spark. Usually a gap between the firing line and the spark line pretty much indicates bad spark plugs or potential bad wires that have bad resistance. Usually our voltage after the firing line should be no more than 6 kVs. Ours is pretty much up to almost 15 kV. That's very high. That's not our normal. Our burn time shows about 1 millisecond. To me, that's pretty much an indication of a lean mixture on this cylinder number 1. Perhaps restricted injector. So now I'm going to go ahead and do number 3, which is the other coil positive. Since the firing order is 11342, so 1 and 3 are companion cylinders. Alright guys, so this is number 3 now. This is also a pause waveform. I paused at frame number 11, just as the comparison of number 1. So I'm going to go frame by frame from 1 through the snap throttle. So here we go. So 11 shows normal. Our burn time is about 1.5. Our KVs are 13.1 at idle. Frame number 12 still shows normal. Actually, our spark line seems to be a little bit high on that one. Potentially due to a lean mixture. Our KVs seem to be normal, less than 20 KVs. And it drops. Frame 16, number 17, number 18, and finally at frame 19, that's where I did a snap throttle. This one also indicates that almost as similar as number 1. Look at our KVs are up there at 29.7. High KVs are usually, like I said, due to lean fuel mixtures. And also the gap between the firing line and the spark line event. That little gap goes all the way to close to 15 kVs, which is not good. Anything over 6 kVs indicates bad spark plugs or potential bad plug wires with bad resistance. You know, I'm not really an expert at really deciphering waveforms for primary or secondary ignition waveforms, but there's always a rule of thumb, and I did my little research on specs. So I'm pretty much comparing, like I said, you know, rule of thumb is to basically compare each cylinder, go one by one, and pretty much, you know, look for any abnormal signals on the waveform. Pretty much these two cylinders are indicating lean mixtures, as indicated in our scan data with our long-term fuel trims, going over positive 10%, which I think our highest was about 13.3, which was indication of the fuel delivery problem, potential restricted fuel injectors. I'm not sure, like I said, you know, I'm not an expert. I wish I was, but at least I know pretty much, just I'll say the basics. You know, I really haven't done much ignition waveforms with primary or secondary. But if you do your research, you could pretty much find potential problems. This problems could be a combination of ignition, plug wires, spark plugs, and like I said, potential restricted injectors. So hopefully, this information helps anyone out there. If you guys know more about these waveforms, comment below this video. Alright guys, so in order to perform these resistance checks on this vehicle, our upper plenum has to actually come off. Why? Because the coil pack number 1 and 2, and also the ignition wires, live just below the intake plenum. As you can see there, our coil pack shows the markings for spark plug number 1, 2, 4, and then 3. The firing order for this vehicle is actually 1, 3, 4, and 2. And then also our connector, which also is going to give us our primary resistance, lives in actually on the other side. I'm not sure if I'm going to be able to show you guys good where where the connector lives, but it's somewhere right there, where you see those wires coming out, actually sticking out. It's a 3-wire connector. Pin number 1 is actually our ignition coil number 2. Our pin number 2 is actually our B plus ASD voltage source, and then pin number 3 is going to be our ignition coil number 1, and that's going to allow us to measure our primary resistance. Alright guys, so I guess the next step is to remove this upper intake plenum and then perform these resistance checks. Alright guys, so before I do any primary or secondary resistance in our ignition coils, and also in our plug wires, and visual inspection in our spark plugs, I'm going to check the fuel system first, just for the fact that our data scan showed a potential fuel delivery by looking at the long-term and short-term fuel trims. As we raised the RPM, we saw that our fuel trims went high, above positive 10%. And also by looking at our secondary waveforms during our snap throttle, we saw that we had some lean mixtures. So to me, that indicates a potential fuel delivery by either a weak fuel pump, potentially clogged fuel filter, or dirty / restricted fuel injectors, maybe more in our number 3 injector, which is causing that pending P0303. So the first test to this fuel system diagnosis, I'm going to start with the fuel injectors by ohming each one and then comparing them. So I'm going to set up and then show you guys. Alright guys, so for injector number 1, our resistance check is about 12.7 ohms. For injector number 2, it also shows about 12.7 ohms. For injector number 3, it also shows approximately 12.7 ohms. Alright, so finally the injector number 4, it also is showing about 12.7 ohms. Alright, so I'm here actually showing you guys the resistance results from our 4 injectors. It appears that all 4 were at 12.7 ohms. I really couldn't find the specs for this vehicle with the resistance of the injector. I checked all data in Mitchell, both of them did not give me that information, so I did a Google search and I did a normal range for port fuel injection, and it gave me within 10 to 16 ohms. So I'm going to use that as our baseline to compare our injectors. So far our injectors are within that spec, but it doesn't really mean that our injectors are actually good. That's just resistance. There's showing that our coil windings inside the resistor, the injectors, are actually good, but injectors tend to actually glitch during stress load, during temperature conditions. That's where they actually show signs of glitching. So the next thing I'm going to perform, it's an injector balance / flow test by using a OTC injector pulse tester. I'm going to use a fuel pressure gauge and then perform this test where I'm going to get the rest pressure, and then I'm going to activate the device, the pulse tester, and then watch our pressure drop. And I'm going to do it for all four. I'll probably do this test twice because sometimes the first test doesn't really show glitches until you perform a second test. So the next step, like I said, I'm going to perform an injection balance / flow test, and then finally I'll probably do a pressure check to check our fuel pump pressure, if our fuel pump is actually delivering enough pressure within that 58 plus or minus 5 psi fuel pressure spec for this vehicle. Alright, so next, the injector balance flow test. Alright, so these are the tools that I'll be using. Like I said before, it's a OTC electronic fuel injector tester. I have it at 50 pulses at 10 milliseconds. And I'll be using my scan tool to actually do bidirectional control on the fuel pump. So in this way, instead of going to the ignition every time to just to prime the fuel pump, I could do it with my scan tool by doing a prime on the fuel pump, and I'll be using an OTC fuel gauge. I'm using a OTC adapter, which is number 32, which is right here. Alright, so next thing is to perform that injector balance / flow test. Alright. Alright guys, so I'm gonna prime the fuel pump. I'm gonna do a drop test on injector number 1. Rest pressure shows about 55 psi. The key point to this test is that make sure that your fuel pressure, rest pressure, holds pressure. If you see it drop little by little, that means that somewhere in the fuel system pressure is actually leaking. Make sure to check your fittings on your fuel pressure gauge. Make sure that it's not leaking fuel. So rest pressure is at 55 psi. So I'm gonna hit the injector pulse tester for injector number 1. Let's watch our gauge. Shows about 39 psi for injector number 1. So I'm gonna do number 2 now. I'm gonna prime the fuel pump. Rest pressure is about 55. I'm going to activate the injector tester. So for injector number 2, it's between 38 and 39. So I'll put 38.5. Injector number 3, I'm going to prime the fuel pump. Rest pressure is about 55 psi. I'm going to hit the tester. Injector number 3, which is our culprit pending code, the P0303. Shows about 39 psi. Injector number 4. I'm going to prime the fuel pump. Rest pressure about 55 psi again. I'm going to hit the pulse tester. I have a faulty connection. Hopefully you have a good connection now, so I'm going to hit it. Still no good connection. Sorry about that, guys. Here we go. So injector number 4, it's about 39 psi. Alright guys, so I'm going to perform this test a second time, but make sure that if you could perform this test a second time, make sure to crank your engine over so that you don't hydrolock your engine with too much fuel in the cylinders. Alright, so I'm going to prime the fuel. We'll start with injector number 1 again. Shows about 55 psi. I'm going to hit the injector tester. Shows about 39 psi for number 1. I'm going to do injector number 2. I'm going to prime the fuel pump. Rest pressure 55 psi. I'm going to hit the tester. Shows between 38 and 39, so it's about 38.5 once again. Injector number 3, prime the fuel pump. Rest pressure 55 psi. Shows about 39 psi for number 3. I'm going to prime for number 4 now. psi rest pressure. Number 4 shows between 39 and 40. So on number 4, I'll put 39.5. All right, so I'm here. I'll show you guys the injector balance / flow test results. I did 2 tests. On the first run, rest pressure was at 55 all the way for the 4 injectors. On the pressure drop on injector number 1, it showed about 39 psi. Number 2 showed about 38.5 psi. Number 3, 39 psi. Number 4, 39 psi. I'm kind of disappointed. I really thought that there was going to be a restricted or dirty injectors. Just by the means of these test results, just on the first test, all 4 are actually within spec. The rule of thumb, the highest to lowest, no more than 1.5 psi difference. This is only 0.5 psi difference between 1 and 2. So for now, the injectors seem to be okay. Now in our second test, rest pressure was 55 in all 4 injectors. Injector number 1, it dropped to 39, same as test number 1. Number 2 dropped to 38.5 psi, same as number 1. And then injector number 3, it dropped to 39 psi, which was the same as test number 1. And finally number 4, that one was 39.5 psi. It was actually 0.5 more than the test number 1. The highest to lowest, we're showing 39.5, lowest 38.5, difference about 1 psi, which is still within that 1.5 psi range. So like I said, I was really expecting an injector problem, especially number 3, but just by performing these 2 tests, the pressure drops were within range of each other. The highest was about 1 psi difference. Remember that the rule of thumb, no more than 1.5 psi difference. This test so far shows, within good range of each other of injector drop tests. But the question is a pressure drop within spec? Let's say if, our rest pressure was 55 and our drop was all the way to 39. What's the difference between 55 and 39? It's about 16 psi difference. My question is 16 psi difference too much or too little? That's the question. I'm not sure if that's within the vehicle's spec. If 16 psi difference, if it's too much or too little, I'm not sure. So I guess the next test I'm going to perform is a fuel pressure gauge on the fuel pump to see if this fuel pump is actually delivering enough pressure during an RPM range of 1500, 2000, 25, 3000. As we saw in our scan tool, as we increase the RPM, our long-term fuel temps was actually increasing. So to me, it still shows a fuel delivery problem. So let me set up and then I'll show you guys. Alright guys, so with everything put back together, I have the engine on. I'm going to perform this fuel pressure check under load. I'm going to increase the RPMs and also watch our fuel gauge to see if it drops. I have my scan data already set up too. I'm showing closed loop, short-term fuel trims fluctuating between negative 3.7, negative 4.7, negative 8, 7. Our long term is stuck at 3.1. Upstream O2 sensor is fluctuating between lean and rich. Our downstream O2 sensor showing about 0.78, a steady signal, which is a rich signal. Anything above 0.45 volts is considered to be a rich signal. So I'm going to increase the RPMs by watching the scan tool first and see if it behaves the same way as before. I'm going to go about 1500. So 1500 is about 9.4. 2000. 2000 still 9.4. Short term is fluctuating between positive and negative. 2100 is at 13.3 long term fuel trim. 25. 25 we're still at 13.3. Short term is actually countering the long term. 3000. 13.3, short term, negative. So at close to 3100, our long term drops to 2.3. So we're still behaving as before. As we did our injector drop test, it seems that all 4 injectors are good, but like I said, I'm not sure that if 16 psi difference between the rest pressure and the drop test, if it's too much or too little. I'm not sure about that spec right there. Now I'm gonna go back to the fuel gauge, and I'm gonna increase the RPMs. So far right now at idle, our fuel gauge showing about 58 psi, which is the range of 58 plus or minus 5 psi. I'm gonna increase the RPM and then watch our needle. Here we go. $2,100, 2,500, 3,000. Our needle is still within that 58 plus or minus 5 psi. So it means it's not a fuel pump issue. It's actually delivering the correct amount of pressure under load. I'm going to do a snap throttle. Should be a very minimal fluctuation. Still at 58 psi. That means that this fuel pump and fuel filter is not the problem. So there's a minimal drop right there, which is still normal. So at this point, I'm kind of stumped. I really thought that this probably was going to be a fuel delivery, just for the fact that our fuel trims tend to go high, and as soon as it goes above 3,000, it drops back to normal. So I guess the next thing I'm going to do is do our resistance checks in our ignition system. I'm going to perform primary, secondary coil resistance. I'm going to check our resistance on our plug wires and do a visual inspection on our spark plugs. So I guess that's the next step. Alright guys. Alright guys, so I'm going to start with the ohming out the secondary ignition. I'm going to ohm out the ignition coil number 1. I already have my ohm scale set to 20k ohms. So I'm going to place one lead to the cylinder number 1 coil. And place the other lead to the cylinder number 4 coil. And this is going to give us our secondary resistance for coil number 1, which is approximately 12.42 ohms. So next, I'm going to ohm the ignition coil number 2. Alright guys, so for ignition coil number 2, it's showing approximately 12.40k ohms. I'll basically place the lead on cylinder number 2 and the other lead on cylinder number 3, and it gave us approximately 12.41. Alright, so the next thing I'm going to do is to perform the primary resistance. Alright, so this next step I'm going to perform, I'm going to show you guys how to check for primary resistance for ignition coil number 1, which has 1 and 4, and then ignition coil number 2, which has 2 and 3. The housing on this coils, it has 3 pins, which are located inside this connector housing. So pin number 1 is going to be the one on your left, which is for coil number 2. Then your middle one, that's your B plus, which comes from your ASD relay. And then pin number 3, which is on your right side, that's for primary resistance for ignition coil number 1. So I'm going to set up and then show you guys. Alright guys, so I'm currently ohming out ignition coil number 2, which is pins 1 and 2, and it's currently showing about 0.9 ohms. It's actually fluctuating between 0.9 and 1 ohm. So next one is going to be for ignition coil number 1, primary resistance. Alright guys, so this is for primary resistance for ignition coil number 1, which is pins 2 and 3. It's currently showing 0.9 to 1 ohm, same as number 2. Alright, so the next step I'm going to perform is the resistance for the plug wires. I'm going to set up and then show you guys. Alright guys, so on this test I'm performing is going to be the resistance for each of the plug wires. I'm currently ohming out the number 1 cylinder plug wire. You basically take one lead to one end of the plug wire and the other one to the other end, and that should give you a resistance, which is for this one's going to be for number 1. It's currently showing about 1.93 kilo ohms. Alright, so this is plug wire number 2. It's currently showing about 2.12 kilo ohms. So plug wire number 3 is showing approximately 2.01 kilo ohms. And for plug wire number 4, it's also showing approximately 2.01 kilo ohms. Alright guys, so I'm here showing you guys the results. I'm going to compare our results to actually specs. I'm going to start with the ignition cables. For plug wire number 1, it gave us about 1.93 kilo ohms. Our spec is between 2.2 kilo ohms to 7.2 kilo ohms, which is our max. That's actually below our spec of minimum of 2.2. Number 2 plug wires gave us about 2.12 kilo ohms, which is just a little bit below our spec. Number 3 gave us 2.01 kilo ohms, which is also below our minimum spec of 2.2. And finally, number 4 plug wire gave us the same as number 3, 2.01 kilo ohms. So far all 4 were actually below minimum spec of 2.2. Especially number 1 was actually below the 2 kilo ohm range. So I'll say just for now, I'm not going to condemn the plug wires just for the fact that they're actually shorter than 1 foot. I believe that these spec numbers are actually for plug wires that are at least a foot or longer. So for now, I'm going to keep the plug wires as potential good. The best way to actually find out if they're good or not is to compare them to known good ones, which I might end up putting new plug wires and comparing the new to the old. Alright, so next I'm going to compare our primary resistance. So for ignition coil number 1, it gave us about 0.9 to 1 ohm. Our spec is between 0.45 to 0.65 ohms, which actually is above our spec of max 0.6. Ignition coil number 2 gave us the same resistance, 0.9 to 1 ohm, which is also just a little bit above our max spec of 0.6. So this is maybe a potential problem, which is causing our lean mixtures and potential pending code of P0303. Now I'm gonna compare the secondary resistance. So for coil number 1, it gave us about 12.42 kilo ohms. Our spec is between 11.5 to 14.7 kilo ohms, which is within spec. Number 2 gave us about 12.41 kilo ohms. That's also between 11.5 to 14.7 kilo ohms. So far our secondary is checking out good. Our primary is just a little bit above spec. In our ignition cable resistance, or just below our minimum of 2.2. So for now, I'll probably say maybe potential primary resistance problem, and maybe a potential ignition wires that are just below our spec of 2.2. Alright, so the next thing I'm going to show you guys is just the firing order for this vehicle, which is 1342. Our DIS positive, which is cylinders 1 and 3, which are companion cylinders, is our positive current, and then essentially our positive voltage, and then our DIS negative voltage is for cylinders 4 and 2, which are companion cylinders. Alright guys, so I've shown you guys the specs for our resistance checks for ignition wires, primary and secondary for our ignition coils 1 and 2, and I guess the next thing I'm going to show you guys is the visual inspection of the plugs to see if they're if the gap looks normal, or if you see any potential problems. Alright guys, so I also decided to do a visual inspection on the plugs. These were supposed to be replaced within 4 or 5 months ago. They're Bosch double radium. They look fairly good for being 4 or 5 months old. I don't really see any problem. The gap seems to be normal. The center electrode seems to be still in good condition. I'm not sure if the camera could pick it up, but I'll say that this is a good spark plug for number 1. So now I'm going to show number 2. Alright guys, so for spark plug number 2, it also looks good. I don't see a problem with the gap. Our center electrode looks nice and pointy. I don't see no signs of deposits on the insulator or tip of the center electrode. For example, if your insulator starts to look brownish, that's indication of a lean mixture. And if your spark plugs tends to look black, that means indication of a rich mixture. And a normal spark plug tends to look this color, whitish. Alright, so I'll say number 2 still looks good. Alright guys, so as I removed the spark plug on number 3, I actually saw that there was actually some oil on the beginnings of the threads on spark plug number 3, which indicates that we probably have a bad valve cover that's actually allowing oil to seep out to spark plug hole number 3, and that's the reason why the spark plug has some oil deposit, as you can see there on this area of the threads, which is pretty much, there's contamination of oil here all the way to the middle of the threads of the spark plug here. And also what I saw number 3 is showing beginnings of actually having that black deposit on the insulator. So this indicates that there is some type of problem on this cylinder number 3, and this is why we have that pending code of P0303. I'm not sure the camera's picking it up, but I do see that the beginnings of that black color on the insulator. So this one doesn't really look like that clean as spark plugs number 1 and 2. Hopefully the camera could pick it up. So this is spark plug number 3, which is probably, I'm pretty sure this is the potential cause, that there's pretty much a rich mixture in this cylinder 3, which is causing the spark plug to turn this color now. And I'm pretty sure also by having oil on the spark plug, I'm pretty sure this oil is causing this this misfire by having moisture in the cylinder 3. Alright guys, so I'm gonna go and check number 4. Alright guys, so before I show you number 4, I'm here showing you guys the indication of the oil, where it's coming from. It's coming from the valve cover gasket, which seals that spark plug tube. And this is why our spark plug has that oil around the threads, which is going down the tube into the spark plug. So this, so this could also be a clue of why, we're also having there's misfires on that. Pretty much, on this cylinder with that pending code of P0303. So this vehicle is going to need a new valve cover. Alright, so the next is to show number 4. Alright guys, so this is spark plug number 4. This one also looks fairly good. Has a good clean center electrode. A little bit of discolored insulator compared to this side. So like on this side, it looks a little bit more cleaner. This one looks a little bit, with a little bit of brownish. But what I also noticed that on the nut part of the spark plug, it also had a little bit of oil deposit on it. So it means that on cylinders 3 and 4, the valve gasket is not sealing those 2 cylinders properly. So it's allowing oil to seep out into the spark plug tube and getting these spark plugs a little bit contaminated with oil. But this one's not so bad like on cylinder number 3. Alright, so for now I'll say that the spark plugs number 1, 2, and 4 look fairly good. But the one that's affected right now is number 3. Alright. Alright guys, so after performing the ohm resistance on injectors, doing an injector balance / flow test on each one, and also performing a fuel pressure check on the fuel pump, and also performing primary secondary ignition resistance, also resistance on the ignition plug wires, and doing a visual inspection on the spark plugs, we at least found that on spark plug 3 and 4 there was a potential problem with oil going inside the spark plug hole, especially on 3 and 4. So that's perhaps a faulty valve cover gasket that's allowing oil to go into those 2 cylinders. Not a lot, but there's some oil that's actually seeping through the seals that seals those spark plug tubes. So after giving you guys the results of each test that I performed, some of them were within spec. There were some that were maybe questionable, especially like the ignition wires. What else? On the primary resistance on coils number 1 and 2, spec shows between 0.4 to 0.6. Our ratings were about 1 ohm, between 0.9 to 1 ohm on each coil. And also by performing our waveforms on our secondary ignition, we saw that there was some lean mixtures in our waveforms. So, but my gut feeling still tells me that our problem does lie within the injectors. I'm thinking they're either dirty or restricted. The owner pretty much has 2 options. Since I don't own a fuel injection cleaning kit, he has the option to either go ahead and replace all injectors, or have the vehicle be taken to a shop and have the fuel injection cleaning service done to it, and hopefully that solves the problem. So depending on in what direction the owner wants to go, this might be a two-part video. Part 1 being the diagnosis, part 2 being the fix. And by the way, I also did a little research on YouTube. I actually found a video from Scanner Danner in which he performed an injector drop test on a Dodge Neon. Pretty much the PT Cruiser and the Dodge Neons are those two vehicles pretty much have the same engine, either the 2.0 or 2.4. So I'm thinking those drop tests that he had on the Dodge Neon, I'm pretty sure those also apply to this PT Cruiser. On his video, when he performed the drop test, his pressure drop, basically his initial pressure was at 57 psi, but when he performed the drop test, his psi dropped between 33 and 34. The bad injector, which was I think on cylinder number 1, that was a faulty one. It was actually leaking fuel. That injector actually dropped to 28 psi. So I'm thinking the normal range of a pressure drop for this injector should be between 33 and 34. For this engine, we saw that our fuel injectors went from 55 psi initial rest pressure, and they dropped all the way to 39. I think injector number 2 was the only one that dropped 38.5 psi. The rest were at 39. So I'm thinking these injectors are not delivering enough fuel to the cylinders, and this is why we're having those lean mixtures, especially as we notice in our waveforms. So depending on what the customer wants to do, be ready for a part 2, the fix. So like I said, I'm gonna take a bite in the bullet and hopefully have these injectors replaced instead of having a service cleaning done to these injectors. So this is Eli the OBA Tech. Subscribe if you like.